What if one day the familiar Earth ceases to be our home? What if harsh reality forces humanity to seek a new refuge among the stars? The worlds we dream of often turn out to be far less hospitable than they first appear. Yet hope does not fade. We continue to search, to plan, and to prepare for the great migration. Where will we go? What mysteries and challenges await us in places where no human has ever set foot? Stay with us to learn about the most realistic resettlement projects and the incredible ideas that could change the future of all humanity. Subscribe to the channel and hit the like button. The most exciting is yet to come. Meanwhile, the only celestial body humans have reached remains the Moon. Despite the absence of an atmosphere and magnetic field, which makes radiation levels extremely high, an astronaut in a spacesuit can spend up to several days on its surface. Compared to other planets, the Moon appears almost hospitable. However, when considering survival on other planets, the picture becomes far gloomier. On Mercury, temperatures fluctuate between -180 and +430 degrees Celsius, and a person would perish almost instantly, within a thousandth of a second. Theoretically, it might be possible to build a base at the poles, where eternal night prevails, or to burrow into underground tunnels for radiation protection, but in practice, survival here is nearly impossible. Venus offers even more terrifying conditions. A dense atmosphere composed of 98% carbon dioxide, pressure 92 times that of Earth's, and clouds of sulfuric acid make staying on its surface fatal in less than a second. It's hard to even say what would kill first. Jupiter and Saturn, being gas giants, give humans not the slightest chance of survival. On Jupiter, death would occur almost instantly from suffocation in ammonia fumes. On Saturn, in addition to the poisonous atmosphere, hurricane winds reaching speeds of up to 1,800 kilometers per hour pose a deadly threat. On Uranus, the situation is even more hopeless. The planet is surrounded by a shell of hot, dense fluid, a mixture of water, ammonia, and methane. Landing here is impossible. A person would dissolve almost instantly. On Neptune, whose atmosphere is similar, the strongest winds in the solar system blow, reaching speeds of up to 2,300 meters per second. Under such conditions, a human wouldn't survive even a fraction of a second. If some planets are fatally dangerous, then which one could become our new home? Is it possible to revive lifeless Mars and turn it into a flourishing world? What secrets does its ancient history hold? And is there a chance to bring it back to life? Mars remains the first and most promising candidate for large-scale human resettlement. Its relative proximity to Earth and conditions that could potentially be adapted for life set the red planet apart from other objects in the solar system. However, terraforming will be essential. Mars's atmosphere is 95% carbon dioxide, radiation levels are dangerously high, and the temperature and pressure on the surface make unprotected presence impossible. Research shows that in the distant past, Mars was warmer, had a denser atmosphere, and stable liquid water on its surface. This suggests that the planet may once have been able to support life, and therefore, with the right technologies, could create conditions for new forms of habitation. The colonization of Mars is a hypothetical project of settling the planet with humans. Traveling there requires comparatively little energy, second only to flights to Venus, and Mars' natural conditions are significantly more favorable compared to other planets or asteroids. Nevertheless, special protective equipment will be necessary for surface activities, as the atmosphere is too thin and unbreathable. Certain features of Mars facilitate possible adaptation. Its daily cycle almost matches Earth's 24 hours, 39 minutes, and 35.244 seconds. The tilt of Mars's axis is also similar to Earth's, allowing for seasons, although at a slower pace. A Martian year lasts 687 Earth days. While the atmosphere is much thinner, only 0.7% of Earth's atmospheric density, it still offers minimal protection against micrometeorites and allows for aerodynamic braking during landings. Martian gravity is about 38% of Earth's, reducing energy costs for launches from the surface. Extensive deposits of water ice have been discovered on Mars, which can be used to produce water and oxygen. The Martian soil contains elements necessary for growing plants, and the carbon dioxide-rich atmosphere could potentially support agriculture with the right technologies and energy resources. This would reduce reliance on closed life support systems that are mandatory, for instance, on lunar or space bases. Additional advantages include the diversity of chemical compositions found in Martian minerals, making the planet a promising source of valuable resources. Moreover, the climate of certain Earth deserts resembles the Martian landscape, and summer temperatures near the equator can reach plus 20 degrees Celsius. Atmospheric pressure on Mars' surface is about half that found on the summits of Earth's highest mountains. Nevertheless, colonization comes with serious challenges. Constant radiation exposure due to the lack of a magnetic field and thin atmosphere poses a health risk. It remains unknown how the human body will adapt to reduced gravity over extended periods. The planet receives only half the sunlight Earth does, and average temperatures reach minus 63 degrees Celsius, fluctuating between plus 30 degrees Celsius and minus 153 degrees Celsius. Liquid water cannot exist on the surface, and the high concentration of perchlorates in the soil complicates the use of local resources for agriculture without prior treatment. Will Mars become a second Earth? Will Elon Musk's plan overcome all the obstacles to create the first Martian city? Elon Musk has been openly declaring his main goal, the colonization of Mars, since 2007. In 2016, he presented the Interplanetary Transport System, ITS project, based on the principles of reusable rockets and fuel production directly on the Red Planet. According to his plan, the first Martian city, Mars City, will begin construction in the 2030s. According to materials from the Alpha Centauri portal, serious steps toward colonizing the planet have already been taken. In 2016, Elon Musk first introduced the concept of a rocket for interplanetary flights. 2 years later, NASA successfully landed the stationary InSight probe in the Elysium Planitia region to study Mars's internal structure. In 2019, SpaceX conducted the first hop tests of the Starhopper prototype spacecraft in Texas, and in 2021, the Perseverance rover landed in Jezero Crater and even carried out the first controlled flight of the Ingenuity helicopter in the atmosphere of another planet. In 2022, SpaceX planned to carry out the first orbital flight of Starship with the help of a prototype Super Heavy booster. New missions to study the planet and its moons are planned for the coming years. All these achievements show that the process of exploration is already underway, and although serious technical and legal issues remain ahead, Musk's plan is gradually moving from a dream to reality. Which other moons and planets besides Mars are scientists considering as potential targets for colonization? What resources from other worlds could play a key role in humanity's future economic development, and what conditions make them promising for life? Titan, the largest moon of Saturn, is considered one of the most promising targets for colonization in the outer solar system. Futurologist Michael Anisimov notes that Titan contains all the key elements necessary to support life: carbon, hydrogen, nitrogen, and oxygen. Thanks to the moon's dense atmosphere, colonists would not need to fear cosmic radiation, and Saturn's radiation belts have a much lesser impact on Titan's surface compared to the belts of Jupiter on its moons. The atmosphere on Titan is so thick that using flying vehicles for movement would be more practical than walking or ground transportation. However, conditions on Titan would require the use of special suits, as the surface pressure is comparable to the pressure experienced under 5 meters of water on Earth, and because of the presence of hydrogen cyanide in the atmosphere. According to the scientific publication, The Space Monitor, Titan is considered an ideal location for human survival in deep space. Water and methane available on the Moon could be used as sources of fuel and life support. Nitrogen, ammonia, and methane could form the basis for fertilizer production necessary for food cultivation. Water extracted from ice would serve not only for drinking, but also for oxygen production. In the context of Earth's depleting natural resources and the need to find alternative energy sources, Titan emerges as an attractive target for humanity's future economic strategies. American scientist Robert Bussard estimated that a mission to Titan involving 400 people and the transport of approximately 24,000 tons of necessary cargo would require funding of about $16.21 billion per year. However, the successful implementation of such a project within a reasonable time frame would require fundamentally new space transportation technologies capable of delivering people to Titan within a few weeks or months rather than years. Nevertheless, the colonization of Titan comes with serious challenges. Low gravity, about 7 times weaker than Earth's, could cause severe physiological problems for colonists, including muscle mass loss and calcium metabolism disorders. Extremely low temperatures, reaching -170 to 180 degrees Celsius, would necessitate the wearing of special protective suits capable of effective thermal insulation under the high atmospheric pressure. The heavy and toxic atmosphere, devoid of oxygen and free liquid water, would require the construction of complex life support systems and powerful energy installations to extract resources. Moreover, data on cryovolcanic activity suggests potential surface instability on Titan, creating additional risks for long-term settlements. Yet despite all the difficulties and challenges, it is precisely in overcoming such obstacles that the future is born. Everything we talk about is only the first step on an endless road. Somewhere beyond the cold silence of space, new lands await us. Harsh, beautiful, demanding courage and dreams. Step by step, humanity will carve its way through silent worlds, learning to live where once there was only emptiness. To walk this path together, to stay tuned to the most important discoveries, and to be part of a great story, subscribe to the channel and follow the news. The most exciting things are still ahead.